Pictured below is a population of a certain type of ladybug that's been genetically altered in a lab. Each number represents the number of spots on these particular ladybugs. There are 10 ladybugs in all in the population. So the letter big N is going to represent the number of population members. There are 10 population members. We'd like to find the average number of spots for the entire population. When we find a population average, though, we're going to give it the Greek letter mu, which is like a U with an extra tail. Let's do that right here. The formula for population average is going to be the sum of all the data pieces divided by the total number of data pieces, big N. So what we're going to want to do is actually add them all up. That's what this says. It's a sum. The Greek letter capital sigma means to add something. So we're going to add all the spots. Okay, and then we need to divide by 10. Our population average is 4. What we're going to do next is select a sample of ladybugs. We want our sample size to be 4, and we want to select them without replacement, which just means that a particular ladybug could only be selected once. So we won't pick the same exact ladybug more than once. So let's highlight 4 of these ladybugs. This is going to be our sample. Little n is the letter given to the number of members in our sample. What is little n? Little n is 4. We selected 4 ladybugs out of the total 10. And now we want to find a sample mean or sample average. The way it works is we'll use the formula sigma x over little n this time. So let's add those up. 0 plus 2 plus 4 plus 4, and we'll divide by 4. This gives us 10 over 4, which is 2.5. Now we'd like to compare our sample average to the population average. Was the sample mean below the population average, equal to it, or above the population average? So I'm going to put my sample mean of x bar equals 2.5 was significantly less than the population mean of mu equals 4. What I'd like you to do is select a different sample for yourself. Go through all the same steps that I did in calculating your sample mean, and see if you get a mean that is below or equal to or above the population mean. You should compare your sample average to the sample averages that others had found. And are there any differences between them? Well, if you selected your sample mean, so if you select a different sample from me, it is actually possible that you could get a different average than I did. In fact, there are many different possible sample means that could be found here. Let's try a different selection. I'll pick these 4. In that case, my x bar would be 2 plus 4 plus 6 plus 8. And then we'll divide by 4. This gives us 20 over 4, which is 5. So differences are expected. Is it possible to get a sample mean of exactly 4, which would match the population mean? It is actually possible. And there's a number of different combinations that would result in that. Even if we just took these, uh, 6, 2, 2, and 6. Let's try that. Let's try that. 2 plus 2 plus 6 plus 6 divided by 4 makes 16 over 4, which is 4. But it wasn't guaranteed that that would happen. Now assume you wish to know the average number of spots for all ladybugs alive right now in the entire world. And that population average is currently unknown because it's impossible for anyone to sample all the ladybugs in the world. There's way too many of them. Would the average spots on a given sample of ladybugs match the true population average? Why or why not? The answer to that question is, it's not likely. That x bar will equal mu. And the reasoning why not is because there are variations in the data. So whenever we take the average of a sample, it's not guaranteed that it's going to match the population mean. I hope this example makes that clear.